Hello friends, this video on Symmetry Part 13 is brought to you by examfear.com. No more fear from exam. Now let us find orders of rotational symmetry for a few examples. So we first take the example of B. So we saw that in case of B, as we rotated it clockwise by 90 degrees, it came to this position. When we further rotated it clockwise 90 degrees, it came to this position. On further rotation of 90 degrees in clockwise direction, it came to this position. And again on further rotation, it came back to the original position. So that means between 0 degree and 360 degree, how many identical position it came across? This is the only identical position. So that means the order of symmetry in this case is 1. Let us take the example of this cross. This example also we had taken before. So this is the original position. Let us rotate it by 90 degree in the clockwise direction. So we come to this position. Let us again rotate it in the clockwise direction by 90 degree and we arrive at this position. When you further rotate it by 90 degrees, you arrive at this position, and on further rotation of 90 degree, you come back to the same position. So basically you see now you have completed 360 degrees. So in one complete cycle, how many identical positions you have? 2. This is 1 and this is 2. So you have a total of 2 identical positions. So the order of symmetry would be 2. So now that we have learnt about both line symmetry and rotational symmetry, let us pick up certain shapes and analyze if that shape possesses line symmetry or rotational symmetry, or can we even come across a situation where a shape has both line symmetry and rotational symmetry. So let us pick up a few alphabets. So let's pick up the alphabet T. So what do you think? Let's first talk about line symmetry. What kind of line symmetry T has? T has a vertical line of symmetry. Something like this. If you draw a line here, so this acts as a line of symmetry, right? So T has vertical line of symmetry. Do you think it has a horizontal line of symmetry? Not really, because horizontally, no matter from wherever you try to divide it into two equal halves, you will not get that. So T only has vertical line of symmetry. Now let us talk about rotation. What happens when you rotate T? So this is the original position. Now let us rotate it by 90 degrees in the clockwise direction. So it would be somewhat like this. If we further rotate it by 90 degrees in the clockwise direction, it would be somewhat like this. On further rotation by 90 degree, it would be like this. And on further rotation by 90 degree, it would reach back to the original position. So what do we see? That in one complete rotation between 0 degree and 360 degree, how many identical positions exist? Only one identical position. So there is no other position which is exactly identical to the original position. So if you talk about its degree of rotational symmetry, so the degree is 1. Perfect. Okay, now let us look at another alphabet M. So in case of M also, if you talk about line symmetry, this also has a vertical line of symmetry. So M also has vertical line of symmetry. Let us talk about rotation. So this is M. When you rotate it by 90 degrees, it becomes like this. If you further rotate it by 90 degrees, it becomes like a W. When you further rotate by 90 degrees, it becomes like this. On further rotation by 90 degrees, it comes back to the original position. So in this case also, there is just one position, that is the original position, which is identical to itself. There is no other position which is identical. So in this case also, the degree of rotational symmetry is 1. Let us look at the alphabet S. So if you talk about the line of symmetry, you see that there exists no line of symmetry. So line symmetry doesn't exist in S. You try drawing a line here or anywhere, you will never see it getting divided into two equal halves. But when you talk about rotation, this is S. When you rotate it by 90 degree, it becomes like this. When you further rotate it by 90 degree, it becomes like this. On further rotation by 90 degree, it becomes like this. And on further rotation by 90 degree, it comes back to the original. So between 0 degree and 360 degree, we come across two identical positions, this and this. So therefore, the order of rotational symmetry for S is 2. So S possess rotational symmetry but no line symmetry. But if you talk about T or M, they possess line symmetry but no rotational symmetry, because all objects possess rotational symmetry of degree 1. That basically means that they do not have any identical positions between 0 and 360 degree. Let us look at the letter O. How about O? If you talk about its line symmetry, you see that there exists a vertical line of symmetry. There also exists a horizontal line of symmetry. So it has both horizontal and vertical line of symmetry. Now, what about rotation? So this is O. So if you rotate it by 90 degree, it becomes like this. If you further rotate by 90 degree, it becomes like this. Further rotate by 90, it becomes this, and it comes back to this. So if you look at identical position, there are two identical positions. Therefore, the order of rotational symmetry is 2. Thank you. Please visit examfear.com for free quality education. You can learn with a simple 4-step learning process wherein you can watch video lessons, you can ask your questions, you can refer notes, and you can take a free online test. We have content for class 6 to 12 on physics, chemistry, mathematics, and biology along with practical videos. So please subscribe to our channel for daily updates. Thank you.